leaving a meeting, and Professor Karlekar now is assigned as a host.
Okay. Okay. Thank you, sir. Okay. Okay. Good afternoon, cadets. Just take 2 minute break.
Good afternoon, sir.
Okay. Take 2 minutes break. Okay. Okay. Okay.
Sir, 4 minutes.
Okay. 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 4 minutes. Okay. Okay.
Thank you,
Because
sir.
my lecture is again back-to-back lecture, 2 lectures done. So this is third lecture. Okay. So take 4 minute break. Then I will start. Right.
Excuse me, sir. Hello, sir.
Okay, cadets. Good afternoon to all.
Good afternoon, sir.
Good afternoon. Okay. I think all are ready now. All right. Okay.
Yes, sir.
All right. I think this is your last lecture, right? This is your last lecture, or yes, this is your last lecture, right? No problem. So we will start today. Just a minute, cadets. First of all, I will share my screen. Okay. Screen is visible. Right, cadets? Screen is visible to all.
Yes, sir.
Very good. Okay.
Yes, sir.
Right. So
Yes.
okay, got it. Okay. Because from because of network issue, means, some are very clear and okay, right. That is right. So our topic is same. That is basic electronics, semiconductor theory. So till now, we had already discussed about semiconductor, the property of semiconductor, then p-n junction diode, the formation of p-n junction diode, the the properties of p-n junction diode, okay, like that. Okay. Then the majority charge carriers, minority charge carriers, negative charge, positive charge, everything you know very well now, right? So the next part of this, okay, excuse me, sir, you haven't shared this PPT with us. See, okay, in the JIT, just wait for one day more, because I want to add some points in PPT, okay, or in notes. So because of that, some delay is there. So I will upload these PPTs definitely. Not uploading, I will send this PPT on our group, WhatsApp group. Okay, so wait for one day. Okay, because Friday and Saturday no lecture to me, because Abrar sir will conduct lecture. So that time I will manage these things and I will upload that things. All right. Okay, so give me one day only. Okay. Right. So let's start here. That is semiconductor theory. As per syllabus again, one point is written here, that is applying DC voltage across PN junction or biasing a PN junction. Applying DC voltage across PN junction or biasing a PN junction means what? Here, obviously, you have to apply DC voltage only. DC voltage only, not the AC voltage. Okay, AC voltage concept is something different. Okay, so AC voltage is not there, only DC voltage. So here there are two type of bias, two bias conditions. Two bias conditions in diode, PN junction diode. First one is forward biasing. When external DC voltage applied to the junction is in such a direction that it cancels the potential barrier. When external DC voltage applied to the junction is in such a direction that it cancels the potential barrier, thus permitting current flow, it is called forward biasing. Thus, permitting current flow, it is called forward biasing. Right? So this one is a PN junction diode here. Positive terminal of battery is connected to P-type semiconductor here, and negative terminal is connected to N-type semiconductor. So obviously N-type semiconductor means what? Electrons are there. This negative terminal again inserts so many electrons here, okay, continuously. And because of positive terminal, holes goes on increasing, right? So from this side and this side means the flow of holes and flow of electrons is towards this junction, So obviously it will cancel the potential barrier. And thus permitting current flow, it is called forward biasing. And actual current will flow through this diode from negative terminal of battery to positive terminal of battery through this PN junction diode. That is actual current flowing through this diode, right? That is forward biasing. The next point is what? Reverse biasing. The reverse biasing means what? Again, a reverse connection. Negative terminal of battery is connected to p-type semiconductor and positive terminal is connected to n-type semiconductor. In the previous one, negative terminal goes to n-type terminal, positive goes to p-type terminal. But now negative to p and positive to n-type. That means you are applying a reverse voltage across PN junction diode. Right? So obviously positive terminal here, so electrons are attracted towards this one, and negative terminal here, so obviously holes are attracted towards negative terminal. So obviously in this way, if holes and electrons are in opposite direction, this depletion region or potential barrier continuously goes on increasing in reverse bias, and it is called a reverse bias. When the external DC voltage applied to the junction is in such a direction that potential barrier is increased, it is called reverse bias. Clear this point, cadets? Forward bias and reverse bias. Right. I hope this point is clear. Right. Okay. The next point is current flow in a current flow in a forward biased PN junction. Okay. So current flows through this PN junction diode if it is connected in forward bias only. Otherwise, no current will flow through that diode. That's all. Okay, so no any explanation on this diagram. Obviously, negative terminal is connected to n-type semiconductor, positive terminal is connected to p-type semiconductor. So because of that, number of electrons goes on increasing in this area. That number of electrons continuously flowing towards this junction breaks, potential barrier overcome, and electrons goes to p-type semiconductor. That electrons gathered in this area because holes are moving towards this junction, right? So electrons moving towards this area, this electrons goes on increasing here, and that electrons again goes to positive terminal of battery. So actual current means, as per electron theory, electrons are moving from negative terminal of battery to positive terminal of battery like this, and actual current will flow in forward biased PN junction. Right, current flow in forward biased PN junction. So this is your diagram for that. Right. The next point, volt ampere characteristics of PN junction. See, cadets, if you have any query, ask me on that time only. Okay, so I will explain that part again if you have any difficulty. Volt ampere characteristics of PN junction or VI characteristics of diode. Volt ampere, so because of that, obviously that is VI characteristic of diode or PN junction diode or crystal diode. Everything is same, right? So this one is a circuit arrangement for that, or experimental setup for VI characteristics of diode. Okay, maybe question is there like that. Draw and explain experimental setup of VI characteristics of diode. So this is an experimental setup for that, right? So here one battery is used. This one is a DC voltage source. One switch is used here to switch on and switch off this supply. Then this one is, what is this, cadet? What is the symbol of this? Means
Variable resistor.
Very good. Variable resistor or rheostat like that. Okay.
Rheostat.
Right, rheostat. So this one is a variable resistor or rheostat used here to increase or decrease the voltage across this PN junction diode. So suppose this one is a load resistor or limiting resistor, whatever you want, you just go through that. Okay, no problem. So suppose This one is a load resistor. Suppose LED or suppose any light is connected in series. Okay. Then milliampere meter is there to measure the current flowing through that diode. Okay. Through diode as well as through load. Obviously, this is in series. Then this is goes to positive terminal of PN junction diode. Okay, that means anode of PN junction diode. See here, positive terminal of battery goes to anode of PN junction diode, and negative terminal of battery goes to cathode of this diode. Cathode is connected to negative terminal of battery. That means this circuit arrangement is in forward bias, right? Sorry. Same time, you have to measure voltage across this diode. So because of that, this voltmeter is connected in parallel with this diode. So this is a circuit arrangement for VI characteristics of diode. That's all. Right? Clear this point? Okay. So if any question is there, or if see, because you have to perform this practical in our electronics lab, VI characteristics of diode, that is written in your syllabus, right? So this type of arrangement is there in our lab, something different, but the actual circuit diagram is like this. Okay. So the VI characteristics of diode. Just go through this characteristic. Very simple concept. This region is a forward bias region because voltage is positive. Voltage is positive means anode is connected to positive terminal, cathode is connected to negative terminal of battery. So this one is a forward voltage. So obviously current flowing through that diode is forward current. That is actual current because of majority charge carriers. So that current is in milliampere. See here, forward current is in milliampere. Same time, this one is a reverse bias voltage. That means this one is VR. Okay. Negative terminal of battery is connected to P-type semiconductor or the anode, and positive terminal of battery is connected to cathode. That is a reverse bias. So that time this voltage is a reverse bias voltage, and the current flowing through that diode is because of minority charge carriers. So obviously that current is very, very less as compared to forward current. That's why this current is in microampere. Remember, cadets, here don't write milliampere. Because see here, this one is 400 milliampere and here 200 milliampere. So that is wrong. Okay. This one is 400 microampere. Very less current will flow through that diode in reverse bias. It is in microampere, it is in milliampere. These two currents are very important, cadets. Okay, this is milliampere, this is microampere. So don't do any mistake in your answer, right? Okay. So this current is very, very less current in a reverse bias. Then now we will discuss about this characteristic. Okay. See here, suppose voltage applied to this diode is 0. Okay, that means at point O, 0 voltage is applied here. So obviously no current will flow through that. That means that switch is in off condition. Okay, K switch is in off condition. So obviously no voltage applied to that diode, no current will flow through that. Okay, that is our first condition. No any external voltage is applied. Right. Then after that, in forward biasing means this region. In this region, as voltage goes on increasing, continuously goes on increasing, don't go through these readings or the numbers written here, because that is not actually correct numbers written here now. Okay. So as this voltage continuously goes on increasing, at one particular point, means all of you knows about barrier voltage or potential barrier of that diode. Okay, germanium diode means 0.3 volt is required, and for silicon 0.7 volt is required to overcome the junction resistance, right? So because of that, see here, up to 0.7 or 0.3, very small current will flow through that diode. Very small current will flow through that diode. So because of that, this curve is non-linear curve here, non-linear curve here, right? Very small current will flow through that diode. And at that voltage, that means barrier voltage, okay? At 0.7 or 0.3 volt, the current starts increasing rapidly, okay? And this characteristic is almost linear characteristic, because in this area that diode will behave like a conductor, okay? In this area it is not a pure conductor, okay? Because as voltage goes on increasing, so thermal energy goes on increasing, so its conductivity goes on increasing. So because of this point, at barrier voltage, current starts conducting rapidly through that diode. So this graph is a linear graph and this graph is a non-linear graph. OB is a forward bias of this diode. OB area is a forward bias of diode. OA is very small current, because up to barrier voltage small current will flow, and after barrier voltage large current will flow through that diode. That is a linear current, right? This is a forward biasing of diode. Vi characteristics of diode in forward bias. Now in reverse bias, okay? This point is clear, cadets? This point is, I think this point is clear, right?
Yes.
Okay. Right. Now reverse bias. This is a reverse bias. See here, in forward bias, the breakdown, the barrier voltage is only 0.7 volt or 0.3 volt. That means that much voltage is there, that diode goes in on state. But in reverse bias, obviously you have to apply much more voltage for conduction of that diode. Actually, this characteristic is not in use anywhere, because diode is a unidirectional device, but it will work in reverse direction also because of minority charge carriers, right? So because of that, obviously here the voltage range is not 0.7 or 0.3. That voltage range is 15 volt here on this graph. Okay, on this graph, this voltage level is 15 volt. So up to 15 volt, see, up to 15 volt, very small leakage current in microampere flowing through that diode in reverse bias. Up to 15 volt, very small leakage current, that is according to this 100 microampere, nothing is there. That much current will flow through that diode because of minority charge carriers, right? But if the 15 volt reached and again the reverse bias voltage continuously goes on increasing, that time very high current will flow through that diode in reverse bias, okay? Reverse saturation current. This current is known as reverse saturation current. So this voltage, at this voltage, the current goes on increasing in reverse bias. That voltage is known as breakdown voltage or reverse breakdown voltage of diode. Okay, so this is a reverse characteristic or reverse bias characteristic of diode. Actually, we are not using diode in reverse bias anywhere. Normal diode or crystal diode, normal diode or crystal p-n junction diode. Okay, so this is a reverse bias characteristic of diode, right? Now see, this is again same, but here this point is mentioned here, that is Zener breakdown or avalanche breakdown. Okay, same thing, that is breakdown voltage is there. So after breakdown voltage, very high current will flow through that and diode may burn out in this area. So I will explain that part also. This one is a reverse breakdown voltage. This is a reverse characteristic of diode. And here this knee voltage is clearly mentioned. See here, at this point, up to this point, this is non-linear or very small current will flow through that. And after this, the characteristic is almost linear because current goes on increasing rapidly, depend on the voltage. Voltage in this area almost remains constant, only current goes on increasing. This is ideal characteristic of diode. Actually, this graph is like this straight line. Okay, but practically not possible. So because of that, some voltage variation is there, and because of that, your graph is like this. This is a characteristic of diode in forward bias. So this area is the useful area of diode in your application, this area. Okay, right. So this one is a forward current, milliampere, reverse current, microampere, forward voltage plus V, minus voltage, reverse voltage minus V. That's all. Clear this point? Clear these characteristics? If this graph is clear, then whatever part written here in this slide, that is very easy to understand now. See, zero external voltage. When the external voltage is zero, that means the K switch is open. The potential barrier at the junction does not permit current flow. Means voltage is not applied. Therefore, the circuit current is zero as indicated by point O in figure. O in figure means in characteristics. Okay. O, A, B, that characteristic is shown here. Right. So at O point, no current will flow through that diode. Forward bias. With forward bias to PN junction, that is P type connected to positive terminal and N type connected to negative terminal, the potential barrier is reduced. Potential barrier goes on decreasing as voltage goes on increasing. Okay, 0.1 volt, 0.2 volt, 0.3 volt, continuously potential barrier goes on decreasing. Okay, some resistance is there, but goes on decreasing. So that time the current flowing through that diode is shown here, that is non-linear curve. At some forward voltage, that means 0.7 volt for silicon and 0.3 volt for germanium, the potential barrier is altogether eliminated. Potential barrier altogether eliminated, and current starts flowing in the circuit. That is a linear graph. Shown in the characteristic. See, from now onwards, the current increases with the increase in forward voltage. So obviously, as forward voltage continuously goes on increasing, the current goes on increasing rapidly. This is the characteristic of diode in forward bias. Thus, a rising curve OB is obtained with forward bias as shown in figure. OB means OAB, like that. Okay. So in this graph, from the forward characteristic, it is seen that at first means the region OA, the current increases very slowly and the curve is non-linear. Current increases very slowly and the curve is non-linear. It is because the external applied voltage is used up in overcoming the potential barrier. Okay, potential barrier is not eliminated till now in this area. Okay, not eliminated in this area from O to A. Once the external voltage exceeds the potential barrier voltage, the PN junction behaves like an ordinary conductor. That time, the current starts flowing through that diode rapidly, depend on applied voltage, obviously more than 0.7 or 0.3 respectively for that germanium or silicon diode, right? Therefore, the current rises very sharply with increase in external voltage. Region AB on the curve is almost linear. The curve AB is almost linear. Okay, so this is about the forward bias characteristic of diode. Right, cadets? This is forward bias characteristic. I think forward bias characteristic is clear.
Yes, sir.
Okay, very good, very good. So we will discuss about the last point here. Last point means the characteristic last point, that is reverse bias. Okay, just go through this one because nothing is there again, because already discussed about this one. With reverse bias, the PN junction, reverse bias to the PN junction, that is P type connected to negative terminal and N type connected to positive terminal, potential barrier at the junction is increased because of reverse bias. Therefore, the junction resistance becomes very high and practically no current flow through the device or flow through circuit. Okay, or PN junction diode, whatever. Okay. But in practice, a very small current of the order of microampere flows in the circuit with reverse bias as shown in the reverse characteristic. This is called reverse saturation current IS, and it is due to the minority carriers, majority carrier and minority carrier. This point already discussed in the last lecture. The actual current flowing through any device is because of majority carriers, and very small current will flow through device because of minority carriers present in the device.
Sir,
Right? Yes.
so basically, what is the use of potential barrier in biasing?
Okay. Actually, this is not a use. Okay. Potential barrier is there obviously because of your PNN junction is junction formation, because if you are joining two semiconductors, P type semiconductor and N type semiconductor, because of that depletion layer formation is there. That part already discussed in the last lecture, right?
So that I am also.
Right. Okay, so because of that depletion layer is there, so obviously you have to break that depletion. Okay, so that's why that much voltage means what? If germanium diode is there, 0.3 voltage is required to break that depletion layer, and 0.7 voltage is required to break that PN junction in to break that depletion layer in silicon. Clear now?
Okay, sir.
Okay, so because of that, see, ideally, if you are discussing about ideal diode, this depletion layer is 0. Okay, ideally. But practically, if junction formation is there, so obviously 0.7 or 0.3 volt is required because of depletion layer. Right? Okay. I think your answer is means your question is clear, right? Okay.
Yes.
Right.
सर
Yes.
सर अभी हम पीछे पढ़ रहे थे कि सर पीछे स्लाइड पे जाना, प्रीवियस स्लाइड.
ओके, हाँ.
सर यहाँ पे रिवर्स बायस में जो पोटेंशियल बैरियर है इंक्रीजेस, बट फॉरवर्ड बायस में कम हो जाता है. ये पोटेंशियल बैरियर बढ़ने कम होने का क्या रीजन?
ओके, अरे ये तो फॉरवर्ड बायस और रिवर्स बायस में ही हमने बोला था ना. जस्ट मिनट. ओके, बढ़ने और कम होने का रीजन यही है. सी, दिस वन इज फॉरवर्ड बायसिंग. ओके, यहाँ पे होल्स टुवर्ड्स जंक्शन जा रहे हैं और इलेक्ट्रॉन्स टुवर्ड्स जंक्शन जा रहे हैं. ऑब्वियसली यहाँ पे तू क्या करने वाला है? वोल्टेज बढ़ाने वाला है.
यस.
वोल्टेज बढ़ाएगा तो ये क्या होगा? ये डिप्लीशन रीजन, ये दोनों अगर यहाँ पे आएंगे तो ये कट हो जाएगा. मीन्स ये डिप्लीशन रीजन का रेजिस्टेंस कम हो जाएगा. इलेक्ट्रॉन्स यहाँ पे बढ़ेंगे, ये क्रॉस करके पी टाइप सेमीकंडक्टर में जाएंगे. समझ में आ रहा है?
Yes, sir. Yes, sir.
Okay, and in reverse bias, this flow is opposite. So because of that, ये holes यहाँ पे जाएंगे, electrons यहाँ जाएंगे, तो ये depletion region बढ़ते जाए, right? So obviously
Yes,
current will flow, right? Okay, good. Okay, so reverse bias, right? Okay. Then the next points that are the parameters of PN junction diode. Parameters of PN junction diode. Knee voltage or cut-in voltage. This parameter already discussed in the characteristic of PN junction diode. forward bias characteristics of diode. So this is your answer for that. This is the definition. It is the forward voltage at which the current through the junction starts to increase rapidly. Okay, after 0.7 or 0.3 volt for in silicon or germanium respectively, the current goes on increasing. Okay, so that voltage is known as knee voltage or cut-in voltage. See here, when a diode is forward biased, it conducts current very slowly until we overcome the potential barrier. So up to potential barrier, the current flowing through the diode is very, very small current. After that, actual current starts increasing rapidly. So that is a knee voltage of diode. For silicon PN junction, potential barrier is 0.7 volt, whereas it is 0.3 for germanium junction. This is a knee voltage or cut-in voltage. Silicon 0.7 is required here to break the potential barrier. Okay, and 0.3 is required in germanium to break the potential barrier. After that, after knee voltage, after this voltage, current goes on increasing rapidly. Okay, forward current in milliamp. Forward current in milliamp. Right. So this is the cut-in voltage or knee voltage of PN junction diode. Right. Okay. So this is a common parameter. Common parameter means what? If your diode is germanium diode, then obviously cut-in voltage is 0.3, and silicon diode, obviously the cut-in voltage or knee voltage is 0.7. So no any information is required from manufacturer for knee voltage or cut-in voltage. If silicon diode is there, then obviously 0.7, and germanium 0.3 is there, right? So because of that, this data is not written, knee voltage is not written on data sheet of diode. Okay, manufacturer will not give any information about that one, because obviously that is 0.7 or 0.3 ideally, right? Okay. The next parameter is breakdown voltage. Next parameter is breakdown voltage. Breakdown voltage or reverse breakdown voltage. Okay. This parameter is mentioned on data sheet by manufacturer only. We will not decide breakdown voltage or reverse breakdown voltage. Because of doping level, that breakdown voltage may increase or decrease, okay, in reverse bias. So because of that, see here, it is the minimum reverse voltage at which PN junction breaks down with sudden rise in reverse current. Okay, it is the minimum reverse voltage at which PN junction breaks down with sudden rise in reverse current. So here, once the breakdown voltage is reached, the high reverse current may damage the junction. Okay, that point already discussed in the VI characteristic. 15 volts shown on that VI characteristic in reverse bias. If the voltage continuously goes on increasing after breakdown voltage, so obviously the high reverse current will flow through that diode, and that diode may burn out or diode may damage. Okay, therefore care should be taken that reverse voltage across a PN junction is always less than the breakdown voltage, always less than the breakdown voltage. If it is greater than breakdown voltage, obviously diode may burn out in reverse bias, right? So this parameter is mentioned on data sheet by manufacturer only. We will not decide breakdown voltage. Okay, manufacturer will decide breakdown or reverse breakdown voltage, right? Okay, so if any number is written on that data, diode, you just search data sheet of that diode, whatever is written on that data sheet, according to that you have to use that diode in your circuit. Okay, whatever the design part is there, right? Okay, I hope this one is clear, right? Okay.
Yes, sir.
All right. The next parameter, this is also mentioned, this parameter also mentioned on data sheet of diode, maximum forward current, because again manufacturer will decide the rating of this current flowing through that diode. Okay, see here, it is the highest instantaneous forward current, highest instantaneous forward current that a PN junction can conduct without damage to the junction. Highest instantaneous current. That means suppose 10 milliampere current is the rating or the maximum forward current rating of that diode, and that diode is connected in series with the load. That load current capacity is 15 milliampere. Current capacity of that load is 15 milliampere. So obviously, because of series connection, 15 milliampere current will flow through that diode, and that diode may burn out. Okay, so obviously in your design part, you have to think about that diode. Diode current rating is 10 milliampere, so obviously you have to select. Means that selection part is, I'm talking about that selection part in inverse or means reverse order. If the load current is 15 milliampere, so obviously you have to select diode of maximum forward current rating is 18 milliampere in that case. Okay, I think the whatever explanation given, that is clear, right? If the diode is of 18 milliampere, load is of 15 milliampere, that is good. But if reverse, then obviously that diode may burn out, right? Okay. Manufacturer's data sheet usually specifies this rating. Okay, see here now. If the forward current in a PN junction is more than this rating, the junction will be destroyed due to overheating, because the current continuously goes on increasing because of that load, whatever the device connected in series. So obviously that diode may burn out, right? Because of overheating. This is maximum forward current mentioned by manufacturer. See, why I am talking manufacturer data, because it is written in your syllabus also. Okay, the parameters of diode mentioned by manufacturer data. You just go through that syllabus or CHLP. I will send the CHLP also on Saturday. Okay, because I'm working on that, and one means sign is sign is required from principal sir. So after that I will send that one. Right, so that is mentioned in your syllabus, manufacturer data sheet. Okay, I think clear this point also. Maximum forward current. The next point is peak inverse voltage. Peak inverse voltage. So obviously peak inverse voltage means what? Inverse means what? Reverse. Inverse means what? Reverse. So the idea is, see here now, it is the maximum reverse voltage. It is the maximum reverse voltage that can be applied to the PN junction without damage to the junction. Without damage to the junction. I know this PIV rating is something confusing, because reverse breakdown voltage is there, and again peak inverse voltage is there. Okay, so don't bother about this. I will discuss about this PIV rating in application of diode, because now whatever I am talking, that is again a confusing for you, right? Just go through this one, and I will discuss about this PIV rating during application of diode as a rectifier, right? Okay, see here. If the reverse voltage across the junction exceeds its PIV, the junction may be destroyed due to excessive heat. Obviously, if PIV rating of the diode is given 15 volt, and if the applied voltage is 17 volt, so obviously that diode may destroy because of excessive heat. So the point written here is the peak inverse voltage is of particular importance in rectifier service. Okay, so that's why you just go through this slide now. I will discuss about this PIV rating in detail during that part, or during the application of diode as a rectifier. Okay, because I know breakdown voltage is there, then peak inverse voltage is there. So what is meaning of this, sir? Okay, so that time I will explain both these things again. Okay, right. A PN junction, that is a crystal diode, is used as a rectifier to change alternating current into direct current. In such applications, care should be taken that reverse voltage across the diode during negative half cycle of AC does not exceed the PIV of diode. I think this line, last line, this is very important. Care should be taken that reverse voltage across the diode during negative half cycle of AC does not exceed the PIV of diode. See now what I'm talking. Suppose you are using this diode in rectifier service, rectifier circuit. Okay, so that time positive half cycle and negative half cycle, because AC you have to convert in DC, right? So positive half cycle, during positive half cycle of 15 volt, during positive half cycle of 15 volt, no problem at all for that diode, because after 0.7 volt, the barrier voltage goes on decreasing, means barrier voltage is 0, and continuously current goes on increasing through that diode. So 15 volt in forward bias, no problem at all. But now 15 volt negative half cycle is there, and during negative half cycle again this minus 15 volt came across that diode, okay, and if the PIV rating of that diode is 10 volt, that time that diode may burn out because of minus 15 volt is across that diode. Clear, cadets? Because see, if half wave rectifier is there, only one diode is there, okay, during positive half cycle that diode goes in on state, no problem at all, because that positive half cycle is your output, okay, during half wave means in half wave rectification. But during negative half cycle, minus 15 volt came across that diode, and the PIV rating of used diode is 10 volt. So obviously that diode may burn out in that case. Clear this point, cadet, what I'm talking? Yes or no? Means till now, because definitely PIV नहीं आएगा समझ में. You just go through this one. I will explain this PIV during rectifier circuit. Okay, क्योंकि यहाँ पे वो सब बताना अभी उसमें टाइम जाएगा मेरा ज़्यादा. ठीक है, तो रेक्टिफायर में ये PIV रेटिंग पे हम लोगों को कुछ डिस्कशन करना भी है, तब ये मैं तुम लोगों को एक्सप्लेन कर दूंगा, राइट? ओके, PIV नहीं समझ में आएगा, मुझे भी पता है, राइट? So this is PIV rating of diode. That time again I will use this slide and I will explain that same point, right? Okay, so that is peak inverse voltage. This peak inverse voltage also mentioned by manufacturer on data sheet. Okay, just leave this point, I will explain that point also, right? Okay, so the last point is maximum power rating. Maximum power rating. So maximum power rating is what again? It is the maximum power that can be dissipated at the junction without damaging it. Again, this maximum power rating is mentioned by manufacturer on data sheet. Okay, maximum power rating of that diode is 10 watts. So obviously your load connected in series with that diode, the rating should be less than 10 watt. Rating should be less than 10 watts. Okay, rating should be less than 10 watt. Clear this point? Okay, so that is maximum power. See here, the power dissipated at the junction is equal to the product of junction current and the voltage across the junction. So obviously 10 watt is written, so that is the maximum power handling capacity of that diode. This is also mentioned by manufacturer on data sheet. So these are some important parameters of PN junction diode. Right, cadets?
Yes, sir.
Okay.
Yes, sir.
So this much part is sufficient today, because whatever the remaining part is there, I will cover that part in the next lecture. Okay. So if any query, ask me now. If any query, because 2 to 5 minutes are there. If nothing is there, then obviously I will close this meeting. Okay.
Sir, please
And
explain that maximum power rating.
Sir, instead you can take one offline class also, na sir. We will gather one place and you will come here to teach.
Actually, no problem from means, there is no any issue. But again, if permission is there, then only I will conduct that class. I will discuss with management, and then I will conduct, because that is again a problem for me. Okay.
Yes, sir.
Definitely, if possible, I will give lecture offline also. Okay. That is totally dependent.
Okay.
Okay. Otherwise, whatever your questions are there, if you want your answer, then I will draw something here, and I will explain that part also in this lecture. Right? That is also possible. But definitely, I will talk with management, and if it is possible, definitely I will conduct that class. Right? That is from my side. Means I will take responsibility. I will discuss with Mahindale sir first, and then management, and then I will conduct. Right? Okay. And I will share these things on our WhatsApp group within 2 days. Within 2 days means on Saturday. Okay. On Saturday, I will share all these notes. Right?
Okay, sir. Thank you.
Okay. Okay. Bye. Take care. Jai Hind.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Attendance, I think all are present.
Yes.
All are present.
Okay. Right. Okay. Bye. Jai Hind. Enjoy. Take care.